This video will demonstrate how we can use Excel to construct a binomial probability distribution. After watching this video, you will be able to create a table of possible x values and their corresponding probabilities in Excel using the binom.dist function. Let's consider this example. In a certain region, 23% of the population has blue eyes. Consider a group of 15 randomly chosen people from this population. Construct a probability distribution for x, where x is the number of people in the group who have blue eyes. First, let's confirm that this random variable meets the criteria for being a binomial random variable. 1. Is there a fixed number of independent trials? In this situation, a trial just consists of looking at a person and determining if they have blue eyes. In this group, we have 15 people, so that is 15 trials, and they're independent because the group is randomly selected. 2. Are we able to express the outcome of each trial as either a success or a failure? Success in this case can mean the person has blue eyes. Failure means the person does not have blue eyes. These are complements, and every person will either be a success or a failure. 3. Does the probability of success remain the same from trial to trial? Yes, since the people are randomly chosen. One person having blue eyes will not change the probability of the next person having blue eyes. Note that this may not be the case if the group had family members in it. Since we're told that the group is random, though, we can assume each person's probability of having blue eyes is the same, 0.23. 4. Does the random variable count successes? Yes. This random variable x is the count of the people in the group who have blue eyes. Now that we've confirmed that this is a binomial random variable, let's set up the table in Excel. I'm going to clearly label the table. In A1, I'm going to type number of successes x. To set the column width, I can double-click on the border between the column headings of A and B. In B1, I will type P of x. The left column will be all the possible values x can be. The right column will be the probability for each of those values. Next, I need to list all possible values of x. In a group of 15 people, the smallest number of blue-eyed people I might see is 0. I can see any whole number of people with blue eyes between 0 and 15, which is the sample size. So in A2, I'll type 0. In A3, I'll type 1. Highlighting my pattern in cells A2 and A3, I'll fill down to A17 to list all whole numbers from 0 to 15. In each cell to the right of those numbers, I need to calculate the probability of having exactly that many blue-eyed people. In cell B2, I'll type equals binom.dist. Open parenthesis. Let's pause for a moment and remind ourselves what this function needs next. Notice that Excel gives me a hint about what it's expecting me to put into the function. First, the x value, or number of successes, then comma, then the number of trials, then comma, and the probability of success for each individual trial. The last input Excel needs is either false to return the probability of exactly x successes, or true to return the cumulative probability of x or fewer successes. In a probability distribution, I want to type false for the last input for each of these x values. So, picking back up for our example here, for the x value, my number of successes, I'll click on the 0 in cell A2. That way the cell will update to the rest of the list when I fill down. Comma. Next, the number of trials is 15. Comma. Next, the probability of success in this situation is 0.23. Always use a decimal to give Excel probabilities. Comma. Finally, type false. I do not want cumulative probabilities here. When I press enter, Excel calculates the probability that I'll see exactly 0 blue-eyed people in this group of 15. It's slightly less than 0.02 or 2%. Since I use a relative cell reference in my number of successes, I can fill down to copy and update this formula for all remaining numbers 1 through 15. That's it. Now I've finished constructing the probability distribution for this binomial random variable. We can use this table of probabilities to answer questions about ranges of probabilities and to see the pattern of which x values are more likely. Creating a probability distribution for a binomial random variable works the same way for other situations with different numbers of trials and different probabilities of success. Just update those values in the function. And make sure your table is as long or as short as is required in the problem. For situations with more than 20 or so trials, this process may be too cumbersome, and you may choose another way to answer probability questions in those situations.